Hello, my name is Kim, and I'm here to learn some chemistry with you today. We will be working on lab number 16, periodic trends, which is aligned with unit 5, day 15. Today, all you're really going to need is the simulation, which will be linked on your slides. You're going to need table S and the periodic table in the New York State Chemistry Reference Table. And while not absolutely necessary, a pen and a pencil and some scrap paper or a notebook would also be helpful for you as we do this simulation. Ready to go? This activity will provide an opportunity to examine the periodic table more closely. Our learning goals for this video are to use an interactive periodic table to explore and describe trends across a period and down a group for atomic radius, ionization energy, and electronegativity. You also should be able to provide reasoning for the trends observed in terms of electrons. To get to the simulation, there are two things that you can do. You can click on the link if you are accessing the slides that includes this assignment, or you can just use Google and you can type AACT periodic trend simulation into Google and click on, it should be about the first link that you see. It looks like this. Before we get into the specific questions that you're being asked for this lab, let's take a look at how this simulation works and what you can do with it. So when you are using this simulation, you will notice that it is asking you to choose elements from the table to compare. All of the elements that are green are elements that are selectable. The elements on the table that have a white background are not selectable. I can't click on silver or gold, but I can click on hydrogen or phosphorus. So I'm going to go ahead and I'm going to start by clicking on an element from the periodic table to compare. Notice this element changed from green to black. And I see information about this element if I scroll down. The default setting is to just compare the element to itself. So I see two boxes of information about hydrogen down underneath the table. Got some information about the number of protons, the number of electrons, the first ionization energy, and the atomic radius of hydrogen. I can click Go to Graphs, and I will see the graphs that show the different trends for atomic radius and for ionization energy. So I have some options there. Now let's say I want to compare hydrogen to carbon. To compare hydrogen to another element, I simply click on the other element. I can highlight up to two elements at a time. See that both hydrogen and carbon are now black. And so I see both hydrogen and carbon listed below the periodic table, and I can compare their ionization energies and their atomic radii. If I would like to unselect an element, I simply click on that element box again. Or I can go up to the table and I can hit this arrow to reset. Something to acknowledge before you start taking a look at the data from the simulation. What's cool about the simulation is that unlike table S, it allows you to actively put the data for two elements directly next to each other on the screen so that you're not kind of scrolling your eyes up and down table S on the reference table, so it's nice to use. However, because we are using a second source here, the simulation in addition to our reference table, I do want to acknowledge that there's some discrepancies between what's listed on the New York State Chemistry Reference Table and what you're going to see on the simulation. Don't panic, it's not going to have a huge impact on your work here, but it's worth acknowledging because this is true of a lot of constants in chemistry. So looking at the simulation, let's use phosphorus as an example. On the simulation, phosphorus has a first ionization energy that's listed as 1011.2 kilojoules per mole. Looking at table S of your reference table, however, phosphorus has a first ionization energy listed as 1012 kilojoules per mole. Those values are very close to each other. They are only 0.8 kilojoules per mole away from each other, and they likely just come from different estimates and different degrees of use of significant figures from the two source materials that both of the simulation and the reference table are getting their data from. Atomic radius can be a little bit more dramatic in terms of the difference, but it won't make a difference in the trends that you see. So for example, phosphorus on the simulation has an atomic radius listed as 98 picometers. And if you look at table S, Your atomic radius for phosphorus is listed as 109 picometers, right? So 109 is pretty different from 98 picometers. Again, this just depends on the source that the simulation versus the chemistry reference table is using to get the atomic radius value. All of these values are experimental, meaning that we determine the atomic radius or the ionization energy of an element by doing experiments, and then scientists kind of put their data together and get to what they think of as the best estimate of that value. And so different sources have slightly different values, slightly different accepted values for things like atomic radius and ionization energy. At the end of the day, however, regardless of which one you are using, the simulation numbers or the table S numbers, for this activity, I recommend that you use the simulation. But regardless of which one you are using, the trends comparing one element to another should maintain throughout all of these different sources. So I just wanted to acknowledge that because it will be something that you run into in the future as well, different constant values depending on the source that you are in fact looking at. So we've talked about how to use the simulation. We've acknowledged that we may see some small differences between the values for ionization energy and atomic radius between table S and the simulation. Now let's go through what it is that you're going to be doing as you complete this lab. So you should hopefully have some form of an assignment that probably will look like these slides that your teacher may have given you. And you are going to be using these slides to take your notes to turn into your teacher at the end of this lab. As I said, I personally think it's nice to have a pen and paper and a physical way to write things down as I'm learning because it helps me, but you can just take all of your notes digitally onto these slides. I just personally recommend writing down the trends that you're noticing on paper before going and back and then typing them into the slides, but it's up to you. So once you've gotten to the link, as we talked about, you can read this instruction slide. I just went over the instructions for how to use the simulation, but they're written out for you there. And then you will start to encounter the questions that really make up this lab. So wherever you're seeing a blue box, that's where you're going to go write a response. And you'll notice that there are instructions for how you should use the simulation to collect data. And then there's data tables for you to write in the data that you are collecting. As you go through the simulation, feel free to use notes from prior lessons that you have done to make connections back to think about explaining why we see the trends that we see in atomic radius, ionization energy, and electronegativity. As you finish the activity, you will see that there is an opportunity for you to use another source when you get to electronegativity. So you'll see that there's actually another periodic table that you're going to click on by clicking the link on that slide there that will take you to a periodic table that shows the electronegativity values of all the elements next to each other. Because as you may have noticed, the simulation that we were using didn't actually give us electronegativity values. So while you could certainly use table S to look at electronegativity, you can also use this great link that shows the location of the elements as well as their electronegativities when you're answering those questions. The purpose of this simulation and this lab was to help you better understand the major trends in the periodic table and explain why those trends are occurring. Make sure you're writing in complete sentences as you answer the questions in this lab, and make sure that you're also referring back to prior lessons to really make connections between what you were doing in this activity and what you learned in the past.